Hello everyone, my name is Zhou Yu. Today I'm excited to present the QIM 512 Multimedia-based Instructional Design Assignment 1, Needs Assessment for our project, Optimization of Ceramic Pattern Painting Teaching Process. Our design is built upon the DCC model, demonstration, coaching, and correction, specifically adapted for adult learners. To give you a clear roadmap, my presentation will cover four key areas. The first one, the current situation and our pain point funnel. Number two, the learner profile based on our survey. And number three, key data insights from our SPSS analysis. And then finally is the proposed DCC strategy. Now let's start with why we need this project by looking at the current gaps. Traditional teaching gaps in traditional ceramic painting courses, we identified a significant information loss. Looking at this pain point funnel, we see three core issues. First, passive observation. Learners are often just watching one-way demonstrations. Second, delay feedback. There is no immediate correction during the painting process. Third, a theory practice disconnect. Adult learners struggle to turn design theory into manual skill. To bridge these gaps, we conducted a survey to understand our target audience's specific needs. We collected data from 52 target learners. Our typical learner is a 23-year-old female, often a university student or young professional. However, we found two major constraints. Zero foundation. Over 55% of them have no formal art training. Time poverty. Most importantly, 73% of our learners have less than 1 hour per week available for study. Despite these challenges, their interest remains high. In part 3, we used SPSS to dig deeper into what truly drives their motivation. Our SPSS analysis provided the evidence for our strategy. First, through ANOVA, we found that regardless of art background, all learners consider hands-on practice to be a universal core need, P equal 0.423. Second, our logistic regression revealed that preserving practice as important increases learning interest by a massive 142.7%. Conversely, time constraints were the strongest navigate predictor of interest. These findings directly lead us to our solution. Part 4. A flexible practice-heavy DCC strategy. Our DCC model solves the time vs practice conflict through three stages. First one, demonstration. We provide 5 to 10 minutes micro lectures that fit into fragmented schedules. Number 2, coaching. We offer asynchronous photo feedback and weekly 30-minute live clinics for immediate guidance. Number 3, correction. We use a mistake bank where common errors are anonymized for class reflection. Now let's look at part 5, learning context and resource. To support this, we provide a flexible online environment and recommended budget-friendly starter kits costing between 50 to 80 RMB. We also integrate AI and digital design tools as requested by nearly 60% of our learners. In the end, let's look at the conclusion and instructional goals. In conclusion, our goal is to ensure that 80% of adult learners can confidently master ceramic painting. By moving from observation to a circle of practice and mastery, we turned a difficult craft into an accessible skill. Thank you for your listen. That's all for assignment 1.
Hello, my name is Zhou Xinyue, and in this part of the presentation, I will briefly explain assignment 2, which focuses on instructional analysis and performance objectives. The main aim of this assignment is to show how an instructional goal can be translated into a clear and structured learning framework, rather than staying at a general or abstract level. First, I will explain our instructional goal. The goal of this instructional design is to optimize ceramic pattern painting learning for adult learners. This goal was derived from the needs assignment conducted in Assignment 1, and it functions as a design constraint for the entire instructional process. Our target learners are adult learners, and the instructional model applied is the DCC model, which stands for Design, Collaboration, and Construction. The expected performance challenge is that learners will achieve skill mastery through hands-on practice and collaborative learning. Next, I will explain the hierarchical instructional analysis. This diagram focuses on skill dependency rather than instructional sequences. In other words, it shows how sub-skills support main tasks and how all main tasks contribute to the final performance goal. The main tasks represent higher level cognitive and procedural skills, such as completing ceramic pattern painting and practicing external brush technique. Meanwhile, sub-skills like sketching, color coordination, and targeted brush strokes serve as foundational skills that enable learners to successfully perform the main tasks. This hierarchical structure helps clarify instructional relationships and ensure that learning proceeds in a logically supported manner. After completing the instructional analysis, we formulated performance objectives using major BCC format. Behaviors refers to what learners are expected to do. Condition specifies the tools or learning context provided, and criteria defines how performance success is measured. Using this structure helps ensure that all objectives are clear and measurable. Here are two examples of our performance objectives. For pattern design, learners are required to design a ceramic pattern. Given ceramic grading and sketching tools, the criterion is to produce a peer-approved and coherent design plan. For brush technique, learners are expected to apply targeted ceramic brush techniques. Using standard brush and practice substitutes, learners should achieve at least 19% accuracy in brush stroke execution. This example shows how instructional analysis is translated into concrete performance expectation. Finally, I will explain the alignment and practical significance of Assignment 2. The instructional goal, analysis, and performance objectives are systematically aligned, and the objectives comprehensively cover all key instructional components. This structure framework provides a clear foundation for the next stage.
Assessment 3. Instrument Design Structure. The purpose of Assignment 3 is to design assessment instruments aligned with performance-based learning objectives and to sequence instruction using guideline events of instruction. This assignment is used to assess CLO1, which emphasizes designing multimedia-based instructional materials through learning theories, instructional models, and system thinking. Assessment instrument design structure. Assessment instruments were developed based on the learning objectives from Assessment 2. Each objective is matched with a specific assessment task and produces observable learning evidence. The assessment is designed as a progressive learning sequence consisting of 5 stages: ceramic pattern design, color scheme, and material preparation, brush technique practice, final ceramic painting, and reflection with collaboration. Instructional strategy use Gaia's model. Step 1. Gain attention. Show video and real ceramic samples. Step 2. Inform objectives. Clear explanation of lesson outcomes. Step 3. Stimulate recall of prior learning. Discussion of previous art or painting experience. Step 4. Present content. Slides and live demonstrations. Provide learning guidance. Step 2. Step-by-step modeling and templates. Step 6. elicit performance. Hands-on ceramic painting practice. Step 7. Provide feedback. Structure and peer feedback. Step 8. Assess performance. Rubric-based evaluation. Step 9. Enhance retention and transfer. Reflection and application discussion. Objective and assessment alignment example. The learning objective is to develop a complete ceramic pattern design based on one gift guidelines. Assessment instruments. For this objective include scene identification, composition, and layout analysis, and initial sketch submission. Assessment evidence consists of a design plan document, sketch images, and rubric-based evaluation, showing clear alignment between the objective and assessment. Design rational and system thinking. This instructional design reflects system thinking by integrating learning objectives, assessment instruments, and instructional strategies into a coherent whole. Assessment tasks are sequenced from low to high complexity to support progressive skill development in both cognitive and psychomotor domains. CIS9 events provide a structural instructional flow, where multimedia elements such as videos, demonstrations, and images support different stages of learning, ensuring consistency across objectives, instruction, and assessment.
Hello everyone, I'm Hu Wenting from Group 10. Today I'll present assignment 4 storyboard formative evaluation and prototype. Let's move on to part 1. Starting with a landing page, it introduces our ceramic pattern painting app, highlights the 4-stage flow from learn, practice, create, and reflect, and guides users with a starting learning button. We can say this one start. Next is a course overview page showing the course title, description, learning objectives, including understand motives, master techniques, create designs, and progress indicators. The homepage displays the user's progress and current project with a resume painting button to continue learning. Moving to learning focuses pages, the Learn page offers structured content like ceramic bases and content design. And then the Listen teaching page is the core instructional interface with a progress bar, diamonds, and interactive buttons. And the Learning and the Listen detail page focuses on specific skills, for example, brush technicals, list daily goals, and includes a quick quiz to check understanding. Practice page focuses on 3 key skills: stretching, color ordination, and brush techniques. The practice detail page provides step-by-step guidance. And the create page leads users through actual painting, base coat, pattern stretch, detailing. After completion, the result page shows the artwork and score with option refine or continue. Finally, the artwork display page shows a finished work in full view to boost achievement. And the reflection and peer review page allows users to view peers' work. Now let's look at the formative evaluation. For the expert review, we invited an experienced art educator with visual arts and creative instruction backgrounds, using a 4-section Likert skill questionnaire. The expert agreed that the content is clear, instruction is appropriate, and the technical performance is smooth, but they suggested a more colorful UI and large font size. For the 1-to-1 review, we recruited 5 beginner ceramic art learners, our target users, via a Google Form with Likert skill and open questionnaire. Users praised clear instructions and user-friendly features. However, 3 users found the UI unattractive, and 4 thought the font was too small, consistent with the expert feedback. So, how did we connect the storyboard and feedback to prototype development? First, The 3 key pages of the storyboard define the prototype structure, user flow, and core functions. And second, we optimized the prototype based on feedback. We added more vibrant colors to the UI and enlarged the font size to improve readability. My teammates will continue to introduce it later. Okay, that's all. Thank you.
Hello everyone, I'm Bee, and today is my turn to introduce our apps for you. So let's together to our landing page. First, the landing page will use an optional style background and a casting logins to grab attention immediately. Click Start lead to meaningless login screen. We keep it simple to ensure beginners can access the course quickly without directions. After successful login, user upgrading on the course overview page. The core of the page is clear 5 learning objectives. You can see 3 key objects listen to the screens, understanding creamy motifs, master painting techniques, and create your own design. This gives the learner a clear expectations of the journey ahead. It clearly lists the 3 key goals: understanding motifs, master techniques, and create design. The bottom negatives previews the feel, learn, practice, create flow, giving user a clear roadmap of their journey. And we also can see in the learn models, we chunk complex content into criminal basic and pattern design to avoid information overload. Each selection use icons and tag together to aid memories and guide users step by step. This is the lesson teaching page. We use 3-step scaffolding stages: introduction, demonstration, and practice. The embedded video tutorial is key, showing dynamic skill better than static image, while the bottom promotes immediate action. Here we see detailed brush techniques. The page lists daily goals and future a quick check quiz. By asking immediately questions like about pressures, the system corrects in-fact learning. Moving to practice model, this is a low-stock sandbox for honing basic skill. We divide practice into sketching, color, and brush work, allowing users to experiment freely and reduce analysis before the real creation. This is a concrete page with simulate the ASIC creaming process with its child partner skate and dictating with the 3D vision models. User can rotate it and pay for all angles, experiencing the joy of creation. Upon completions, the system provides a score and encouragement. The positive feedback is a vision of motivation. User can choose a reinforce the work's reflection or continue to the showcase, offering a flexible workplace. These art workplaces, we remove all distractions to freely showcase the user art. Finally, the community page. User can view and review peer work fostering social learning. The reflection sections ask users to record the thought, helping them summarize appraisals and complete the learning loop. From our 4 assignments, a logical journey from need to prototype in our words. We began from the assignments identify the pain point of adult beginners. This directly leads to models performance objective. We list that great designer is a precise response to user needs, not just in mitigation. With goal set assessments, we translate them into star quiz using Garni's 9 events. We integrate the DCC model to ensure a strong compliance between instruction and assessments, keeping the learning path on track. Finally, assessment for materialize the logical into an app prototype. Through formative evolution, we move from theory to user validations, confirming our foundational logical while identifying visual UX improvements. The journey told us that idea is a tight logical chain. Every feature in the prototype must track back to the initial needs. The scientific thing is our most valuable takeaway.